So today we will discuss about linear programming problem and some basic definitions also we will discuss, like the general linear programming problem, and then what is the standard form of an LPP, what is the matrix form of an LPP, and some more definitions we will discuss. So before that, so linear programming problem. So first you have to understand one by one these words. Okay, so linear. So what do you mean by linear? So all of you know linear equations. What do you mean by linear equations? Linear equations means degree is 1, order is 1. That means if the variables involved in the particular problem are of degree 1. That type of equations are called linear equations. Suppose for example, I have given x plus y equal to 5. This is a linear equation or not? This is a linear equation because order is degree is 1. So this is called linear equations. And that means in LPP we will use only linear equations. We will not use second degree equations, polynomial equations like that. In LPP we will use only linear equations. So linear means that all the relationships involved in the particular problem are of degree 1. And that is called linear equations. Okay. So next one is programming. Next term is programming. What do you mean by programming? Programming means planning. So planning, how to solve the problem. You will write several steps. That is nothing but planning. So how to choose the alternatives. There are several alternatives are available. A, B, C, D, like that. So you have to choose. You have to choose a plan. How which activity should be identified first for the available resources. So programming means planning. So problem. What do you mean by problem? Problem means to find the unknown values of the variables. Unknown values of the variables. So problem is what we suppose solve the problem given two equations. What you will identify? You will identify the unknown variables x and y. So problem means you have to identify the unknown values of the variables. Unknown values you can identify, then that is called problem. So now what do you mean by linear programming problem? Linear programming problem means it is a technique. It is a technique to determine. It is a technique to determine. Now we can write on the definition of linear programming problem. So it is called LPP. So it is a technique of determining an optimum schedule of a particular problem with the available resources. That means you have to identify an optimum schedule with the available resources. You can use the available resources and you can find out the optimum value for that problem. That is called LPP, linear programming problem. So next definition we have to discuss is general linear programming problem. Next definition, general linear programming problem. General linear programming problem. General. So it is simply I will write as GLP. General linear programming problem. Simply I will write as GLPP. General linear programming problem. General linear programming problem. So how a general linear programming problem looks like? So right. First I will tell you the definition. Later on I will explain what is the general linear programming problem. Right? GLPP. It is called GLPP. Right? The general linear programming problem. The general linear programming problem is to find n decision variables x1, x2, so on xn, n decision variables x1, x2, so on xn to optimize the objective function. And E is given by right in the next line, maximum or minimum z. Maximum or minimum z equal to C1 x1 plus C2 x2 plus so on Cn xn. C means cost. Okay, x1, x2, xn means decision variables. So C1, C2, so on Cn. maximum or minimum z. Okay. Next line. Write in the next line. Otherwise you can write here where next line where C1 comma C2 so on Cn, where C1 C2 so on Cn are constants are constants satisfying are constants. Okay, next line satisfying m constraints, satisfying m constraints. Constraints, I will tell you what you mean by constraints. Constraints satisfying m constraints, satisfying m constraints. Write in the next line a11 x1 plus a12 x2 plus so on a1n xn. a11 x1 plus a12 x2 plus so on a1n xn is greater than equal to or is less than equal to or equal to b1, equal to b1. Similarly, if you want to write the next constraint, what you will get, one is completed. Now second one, a21 x1 plus a22 x2 plus so on a2n xn is greater than equal to or less than equal to or equal to b2, or equal to b2. If you go on like this, because you have considered m constraints, if you go on like this, the last constraint will be a m1 x1 plus a m1 x1 plus a m2 x2 plus so on a mn xn is greater than equal to or less than equal to or equal to bm, equal to bm. a11 x1 plus a12 x2 plus so on a1n xn is greater than equal to or less than equal to or equal to b1, and xj greater than equal to 0, xj greater than equal to 0, j equal to 1 to so on n, j equal to 1 to so on n, j equal to 1 to so on n. This a11 a12 are constants only. Okay, b1 b2 so on bm are also constants, like c1 c2 so on cn you have written. So all are constants only. So this is called GLPP. In this GLPP, this is called equation 1. Assume that is equation 1. The second part is considered as equation number 2. The second part is considered as equation number 2, and this is the third part. I will consider equation 3. Just put S3. Now we have to learn what is the first part, what is the second part, and what is this third part in GLP. Okay, so how many decision variables you have taken? In general, you have taken n decision variables. So n decision variables, this is a general linear programming problem. Now you have to know what is equation 1, what is equation 2, and what is equation 3. Okay, now see, this equation 1 is called objective function. Now onwards, if a function is given maximum or minimum z, that is called objective function. That means objective function may be maximization type or minimization type. So what is equation 1? Equation 1 is called objective function. It has a name. That name is called objective function. So objective function may be maximization or may be minimization. Okay. Now if you observe the second equation, these are the second equations. So these are called constraints. So what do you mean by constraint means? So constraints is nothing but it should be a inequality types or equal types. Inequality type means it may be greater than equal type or less than equal type. Okay, equality means equal type. So constraint is nothing but it is an equation. Equation consists of inequalities or equalities. So what do you mean by constraints? So constraints, this equation 2 is called constraints. That means constraint may be either inequality type or equality type. Okay, so second equation is called constraints. So constraints may be inequality types. Inequality means greater than equal to or less than equal to, or equality type or equality type. Next, last one. Equation 3. Equation 3 is called non-negative restrictions or decision variables. So equation 3 is called non-negative restrictions. If you observe here, x is greater than equal to 0 and it cannot be negative, 0 or positive. So equation 3 is called non-negative restrictions. Now you can define LPP. So LPP definition I have told. What is the first definition I have told for LPP? LPP is a technique to find or to determine an optimum solution of an available resources of a particular problem to the available resources is called LPP. Otherwise, LPP can be defined. Now, all of you know what is this one? An objective function. This is set of constraints and non-negative restrictions together is called LPP. Now, LPP can be defined. So, what is the LPP definition now? LPP definition is nothing but an objective function, set of constraints. If you take one, this is called constraint. This is set of constraints. Okay. So, an objective function, set of constraints and non-negative restrictions together is called an LPP. Okay. Right. Next slide. Next slide. You can continue. Equation 1 is called objective function. Equation 1 is called objective function. Equation 1 is called objective function, which may be maximization or minimization. Which may be maximization or minimization. Which may be maximization or minimization. Okay. Next slide. Equation 2. Equation 2 is called set of constraints. Equation 2 is called set of constraints. Set of constraints, which may be continuation, commutative, which may be in the form of inequalities or equalities. Which may be in the form of inequalities or equalities. Last one. Equation 3 is called non-negative restrictions. Equation 3 is called non-negative restrictions. Non-negative restrictions. Equation 3 is called non-negative restrictions. Okay. Now this is called general linear programming problem. GLP means it has an objective function. It may be maximization or minimization. A set of constraints will be there and non-negative restrictions will be there. Now, if you want, you can define LPP also. Now, you can define LPP. What do you mean by LPP? An objective function, set of constraints, and non-negative restrictions together is called LPP. Therefore, definition of LPP. Definition of LPP. You can write first definition, otherwise this definition. Okay. So, LPP. Write down the definition of LPP. An objective function, comma set of constraints, and non-negative restrictions. Together is called an LPP. Together is called an LPP. Example. If you want, you can write the example. So LPP means what? LPP means what you have written? An objective function. Okay. So just I will write one example. Any example you can write? Example I am writing. Objective function may be maximization or minimization. You can take any one. So I will take maximum. Maximum z equal to. So generally n decision variables are there. In the problem only two decision variables are there. You will take x1, x2. So I will consider, you can consider a values. So I will consider 5x1 plus 6x2. LPP means all are linear equations only. So order is 1. So 5x1. This is in general n variables. If you have two variables, you will get like this. Okay. Maximum z equal. Now objective function is completed. Next what we have set of instructions. Generally m is the data. In general I have taken m. So sometimes you may get 2 constraints, sometimes you may get 3 constraints, sometimes you may get 4 constraints like that. So you can take any number of constraints. Okay. So that means, so I will take subject to the constraints. So I will write the first constraint x1 plus x2 What you are saying, the constraint may be either inequalities or equalities. It may be in the form of greater than equal to, it may be in the form of less than equal to, or it may be in the form of equal to. You can write any. So I will take x1 plus x2 greater than equal to 6. It is a constraint or not? It is a constraint because the constraint may be in the form of inequalities or equalities. Okay. So second constraint I will take 2x1 plus 5x2 less than or equal to 6. Less than or equal to 6. You should not require that all the inequalities should follow as it is. So some problems have only greater than equal type, some problems only less than equal type, some problems there are mixed. So if a constraint, when do you say there is a constraint? If the constraint is in the form of inequalities or equalities, then you can say that is a constraint. Okay. So now constraints are completed. Only two constraints have to taken in the problem. One is less than equal type, one is greater than equal type. If you want, you can take equal type also. Okay, and how many variables are there? Last step, see this last step. Xj greater than equal to 0 because j equal to 1%. In general, you have taken n variables. Now in this particular problem, how many variables you have? How many variables you have? Only two variables. That means what is it? N x1 comma x2 greater than equal to 0. x1 comma x2 greater than equal to 0. Now this is an LPP or not? This is an LPP. Now see the definition. LPP means what is an objective function? It is there. Objective function, set of constraints and non-negative restrictions together is called an LPP. Together is called LPP. Now all of you understood what do you mean by an LPP? What do you mean by GLPP? GLPP definition is this is in general n variables. I am taking only two variables here. In general, if you take n variables, this is a general linear programming problem. You will get it. I hope all of you understood this one. Okay. Next you have to learn is standard form of an LPP. Now put the side heading standard form of an LPP. 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 Standard form of an LP. Standard form of an LPP. So when an LPP is called standard form of an LPP, so I will tell you three properties. Okay. So first property is objective function is always maximization type. So in standard form, objective function is always maximization type, maximum type. Second point, all the constraints are equality type. All the constraints are equal type. Third one is decision variables are non-negative. So when an LPP is called standard form of an LPP, first condition, what is the first one? Objective function should be maximization type. What is the second one? Constraint should be equality type. And what is the third one? Decision variables are non-negative. So all of you know general LPP. Just now we have discussed general LPP. So general LPP maximization or minimization objective function. But standard form objective function is only maximization. So what you will get? This you will get maximum z only. So the standard form of an LPP is given by next line maximum z equal to because only you will get maximum, you won't get minimum in standard form. Okay. So if you have minimum, you have to convert it to maximum, then only you can consider the standard form. So maximum z equal to same as c1x1 plus c2x2 plus so on cn xn. Already you know general LPP. Just now we have discussed the same concept. Only thing is objective function is maximization type. Already you know GLPP constraints. Constraints may be in GLPP constraints may be less than equal type or greater than equal type or equal type. But in standard form constraints are always equality type. Constraints are always equality type. So what are the constraints? A11 x1 plus A12 x2 plus so on A1n xn is equal to B1. Only equality type you will get. Equality. Okay. So similarly, last constraint. What is the last constraint? Just now we have discussed generally am1 x1 plus am2 x2 plus so on amn xn is equal to bm. And constraints are completed now. And xj greater than equal to 0. Xj greater than equal to 0. J equal to 1 to so on n. J equal to 1 to so on n. If you want to write this into a simple form, matrix form, how can you write this one? This is nothing but otherwise we can do it like that. Next, anyway, we will discuss matrix form. So this is the standard form of an LPP. Standard form of an LPP. Sorry, the standard form of an LPP is given by maximum z and the set of constants always equal to type in standard form. Objective function is maximization type. Decision variables are non-negative. If you want, you can write example. So example, you can write any example. So then maximum z equal to 2x1 plus 5x2. 2x1 plus 5x2 constraints, subject to the constraints. Subject to the constraints. Write the first constant x1 plus 2x2 is equal to 5. You can write any constant which is equal to type. Okay. Second constant 2x1 plus 3x2 is equal to 4. Is equal to 4. You can write n number of constants. Okay, and x1 comma x2 greater than equal to 0. Now this is a standard form of first you have to check. Objective function is maximization type. Constraints are equal type and decision variables are non-negative. That means this is the standard form of an LP. This is called standard form of an LP. So if you want, you can write the properties of standard form of an LP. What are the properties? 3 properties just now I have discussed. What is the first property? Objective function is always maximization type. Constraints are, second point is constraints are equal type and decision variables are non-negative. So I think all of you understood what you mean by standard form of an LPP. So further, while using problems, we will discuss all these forms. That's why I am discussing. Okay. So next one, next form is matrix form of an LPP. Matrix form of an LPP. Matrix form of an LPP. Just I will change here. Matrix form of an LPP. Matrix form of an LPP. Matrix form of an LPP. So matrix form also, an LPP, when an LPP is called said to be matrix form of an LPP, same conditions. What is the first condition? It should be objective function maximization type, constraints are equal type only, and decision variables are non-negative. The only difference to standard form and matrix form is standard form you are taking the constraints like this, and a1 coefficient values you are taking like this, a11 x1 equation type you are taking. Matrix form means you have to consider the matrices. So that means what you will get, that the matrix form of an LPP is given by, if you observe here, so C is a column matrix. That means what is it? C1, C2, so on, Cn. So C1, C2, so on, Cn. Okay, so when multiplication is possible, all of you know the matrices. So A equal to, suppose A is a column matrix. Suppose A is a column matrix 1 by n. And B is the, so when AB is possible, if B is the column matrix means what is that? N by 1. So that means then only the multiplication is possible. I think all of you know, you have learned in intermediate level, at intermediate level, when matrix multiplication is possible. Okay, now C is the column matrix and then X is, C is the row matrix and X is the column matrix. That means what you will get, this is nothing but simply I will write capital C, capital X. What is C? C is the row matrices. Row matrices means C1, C2, so on, Cn. I will write later. Okay, and X is the column matrix. Similarly, this one, this entire thing I will write as simply, this is A11, A12, I will assume as capital A matrices. And this X matrices, X1, X2, so on, Xn means X matrices. This B1, B2, so on, Bm means I will assume as capital B. That means this entire constraints will be treated as what we get now, capital AX equal to, simply capital AX equal to capital B. Capital AX equal to capital B. And last, decision variables are non-negative means X is a matrix which should be greater than equal to 0. X is greater than equal to 0. Now this is called matrices. These are all matrices. C, X, C matrices, X matrices, A matrices, X matrices, B matrices, and this is X matrices. Now you can write down what are these matrices. Okay. So where C equal to, so already I have told C is the row matrices. Row matrices means all of you know C. What is the C value? C1, C2, so on, Cn. Already the standard form we have. Okay. And then X is always a column matrix. Then only multiplication is possible. That means what is that? X1, how many variables are there? X2, so on, Xn. X1, X2, so on, Xn. Next, B is also a column matrix because B1, B2, so on, Bm we have written. So that means B is also a column matrix. B1, B2, so on, Bm. B1, B2, so on, Bm. Okay, and then now C is completed, X is completed, A is completed, and B is completed. So A is not completed, so we can write down A matrices. A is nothing but the coefficient matrix. Coefficient values. What are the coefficient values? Otherwise, I will write here. So this is not here. So I will write A matrices here. So what is A matrices? A matrices are often known as general form A11, A12 coefficient values. So on A1n, A1n. Okay. So on if you write, what is the last values? AM1, AM2, so on AMn. And this is m by n matrices. A matrices is a m by n matrices. Okay. C matrices, you know the order of the C matrices. What is the C matrices? One row, n columns at 1 by n. 1 by n. So this is nothing but n columns. So that means this is nothing but n columns and one row. Sorry, n rows and one column. N rows and one column. Okay. So this is also m rows and one column. M by 1. M rows and one column. So this is called matrix form of an LP. So you have to learn standard form. Standard form and matrix form are same. So standard form you will write the equations, and matrix form you will write the matrices. In terms of matrices you will write. So A is the m by n matrices, and C is the 1 by n matrices. X is also n by 1 matrices, and B is also n by 1 matrices. So this is called matrix form of an LP. This is called matrix form of an LP. So I hope all of you understood the matrix form, standard form. So what are the definitions till now we have discussed? Up to now we have discussed. First one we have discussed is LPP. So what do you mean by LPP? Simply LPP means what? LPP means linear programming problem means what? An objective function, set of constraints, and non-negative restrictions together is called an LPP. Next you have learned general linear programming problem. So for n decision variables, I have given the form. So first one, equation one, that first part is called objective function, which may be maximization or minimization. The second equation is called set of constraints, which may be in the form of less than or equal to, or greater than equal to, or equal type, and which may be in form of inequalities or equalities, and decision variables are non-negative. So next you have learned standard form of an LPP. So standard form of an LPP means objective function is only maximization type, constraints are only equality type, and decision variables are non-negative. Next you have written matrix form. So matrix form also, the only difference is we will write in terms of matrices. Right. So matrix form of an LPP means what? Matrix form of an LPP means objective function is maximization type only, constraints are equality type, and decision variables are non-negative. So you will write in terms of matrices like this. Okay. So the next definition is slack variables. Slack and surplus variables. The next definition is slack and surplus variables. Slack and surplus variables. The next definition is slack and surplus variables. So slack, S-L-A-C-K, slack, and surplus, S-U-R-P-L-U-S, surplus variables. Surplus variables. First I will explain what you mean by slack variable. First I will tell you the definition. So first write down the slack variables. So slack variable definition first I will tell you. Okay, right. The non-negative variable. First write down the definition. Later on I will explain. Okay. The non-negative variable which is added. The non-negative variable which is added to the LHS of the constraint. To the LHS of the constraint. Again I am repeating, the non-negative variable which is added to the LHS of the constraint to make it as equality type. To make it as equality type. Equality type is called slack variable. Is called slack variable. Full stop. Slack variables are used only for less than or equal to type constraints. Only for less than or equal to type constraints. less than or equal to type constraints. Here, one thing I have understood from this definition, what is there? Slack variables are used only for less than or equal to type constraints. Okay, so write an example. So first listen the example, I will explain with an example, then you can understand better. Okay, suppose a constraint, I am not taking the entire Lpp, just I am taking one constraint. You know the objective function maximum type constraints are less than equal type or greater than equal type or equal type. So slack variables are used only for less than equal type constraints, so I am taking only less than equal type constraint. So I am not taking the entire problem, I am taking only one constraint. So suppose a constraint is like this, 5x1 plus 3x2 less than or equal to 5. A constant is less than a constant is like this, 5x1 plus 3x2 less than or equal to 5. Okay, so now read the definition. What do you mean by slack variable? Slack variable is nothing but, if you understood the definition, what is the definition? The non-negative variable which is added to the LHS. So this is called LHS. This part, this entire part is called LHS. This entire part is called LHS. This is RHS. Okay. Now read the definition. The non-negative variable which is added to the LHS of the constraint, LHS of the constraint to make it as equal type. So in graphical method, directly you will consider inequalities as equalities. But in simplex, big M two-phase methods, you won't consider like that. So how a less than equal type constraint is converted into equal type constraint by introducing a slack variable. So whenever you find less than equal type constraints in simplex method, what you have to do, you have to make it as equal type. How will you make it as equal type? By introducing of slack variable. So slack variable is added or subtracted. The non-negative variable is added and a plus. So the non-negative variable is added to the LHS of the constraint to make it as equal type. And why slack variables are required? Slack variables are why it is required to make the constraint as equality type. In graphical method, directly you will consider inequalities into equalities, but in simplex method it is not possible. Okay, so if less than equal type constraint if you find, you have to use slack variables. So slack variable is always added to the LHS of the constraint. Now how many variables are completed here? Two variables are completed. So I will take the next variable. What is the next variable? X3. X3 means what we get now? 5x1 plus 3x2 plus x3, so that inequality becomes equivalent to 5. Equivalent to 5. Now read the definition. Read the definition. The non-negative variable. This is the non-negative variable or not? The non-negative variable. Okay, which is added and plus to the LHS into this part, to the LHS of the constraint to make it as equal type is called slack variable. And x3 is called, what is x3 here? So x3 is called slack variable. x3 is called slack variable. x3 is called slack variable. I think all of you understood. What do you mean by slack variable? Now you can write the slack variable. So by seeing the example, you can write the definition of slack variable. The non-negative variable. Now see, the non-negative variable which is added to the LHS of the constraint to make it as equality type is called slack variable. Slack variables are used only for less than or equal to type constraints. I hope all of you understood this one. Next definition is surplus variable. Surplus variable, reverse of this one. So surplus variable, write down the definition of surplus variable. First I will tell you the definition, later on I will explain with an example. Surplus variable. Same, the non-negative variable which is subtracted to the LHS of the constraint, to make it as equality type, is called surplus variable, full stop. Continuation. Surplus variables are used only for greater than or equal to type constraints. Okay. So take an example. For example, you can consider any one which is greater than equal type. Less than equal type means you will use slack variable. Greater than equal type means you require surplus variable. Okay, so slack variable is added, surplus variable is subtracted. Slack variable is added, added plus. Okay, surplus variable is subtracted. Okay, so that means what is the example? Surplus variable example you can consider. I will consider one constant 6x1 plus 10x2 greater than equal to 5. Greater than equal to 5. Greater than equal to 5. Okay, so now this is nothing but this is a greater than equal type constant. Greater than equal type constant is what we will get. This is nothing but. So I will take surplus variable now because you have to use surplus variables. Already x2 is completed. I will consider x3. Suppose you here x3 is there. So sometimes what happens is, suppose if you want 10x2 plus 3x3 is greater than equal to 10 is there. Is greater than equal to 10. Now how many variables are completed? 3 variables are completed. You can take the fourth one. I am not taking the entire problem. I will take only one constant. I am explaining. Okay. So 3 is complete. X3 is complete. You can take x4. So that means what you will get. This is LHS or not? This is the LHS part. Okay. Now read the definition. The non-negative variable. What is the non-negative variable? You are taking x4. Okay. So that means what is that? 6x1 plus 10x2 plus 3x3. Okay. x4 is a non-negative variable I am taking. Okay. That should be subtracted. Subtracted into minus. Slack variable means added. Surplus variable means subtracted. So that inequality becomes equivalent. So this x4 is called which variable? Surplus variable. So x4 is called surplus variable. It's called surplus variable. Surplus variable. Okay. Now you can write the definition. What is that? The non-negative variable. The non-negative variable which is subtracted from the LHS of the constraint. From the LHS of the constraint to make it as equality type is called surplus variable. So surplus variables are used only for greater than equal type constraint. So now all of you understood what I mean by slack variables and what I mean by surplus variables. Slack variables means what is that? The non-negative variable which is added to the LHS of the constraint to make it as equality type is called slack variable. So slack variables are used only for less than or equal to type constraints. Next definition I have told is surplus variable. What do you mean by surplus variable? The non-negative variable which is subtracted from the LHS of the constraint to make it as equality type is called surplus variable. Surplus variables are used only for greater than equal to type constraints. So today we have discussed all the important definitions. First one we have told what do you mean by an LPP. Next I have told what do you mean by GLPP, general linear programming problem. And next I have told what do you mean by standard form of an LPP, and then matrix form of an LPP, then slack and surplus variables. So all these definitions are important. So for further problems, that means we have finished graphical method. If you want to move further, that means simplex method. So I have told what is the drawback of the graphical method. Only 2 decision variables can be solved by using graphical method. Sometimes the problem 3 decision variables are there. 3 decision variables are there. You cannot use graphical method. So that's why the next method is invented. So what is the next method? Simplex method. So further simplex method, these are the things you have to learn first. What do you mean by LPP, and then GLPP, and then standard form, and then matrix form, and then slack and surplus variables. So equal type constraints we will see further. Later on we will see that equal type constraint. So greater than equal type means we will use surplus variable. Surplus variable is always subtracted. Remember, slack variables are used only for less than equal type constraint. Slack variable is always added. Okay. So the next class we will discuss problems on simplex method. Okay. Thank you.